not that great of an approximation at low energies, but not that far off that one would explain cold fusion. And what's typically done in the fusion experimental arena is you measure fusion rates at much higher energies than the energy in the core of the sun, which is about 1.2 keV. Making measurements in the MeV region so that you have high enough rates that you get your data in a reasonable amount of time. Then the cross-section is converted into the astrophysical function. Cross-section is the astrophysical function, 500 energy times the tunnel coefficient. And it's the astrophysical function, which is a probability once you tunnel through the barrier, gotten into the nuclear well, that the nucleon will stay in the neutral well. Well, they extrapolated that down. They used the same equation, gamma factor for the tunneling coefficient. You got a cross section. That's the input in the standard solar model. Now, I wouldn't dare say what I'm going to say next if I hadn't heard it with my own ears. I was at the talk by John Backwell, who I have a lot of respect for, and then pointing out how he does things with the standard solar model. He said he used experimental cross sections as input data to the standard solar model. And I knew very well that it didn't. It was, in a sense, theoretical extrapolated. We did an extrapolation which couldn't solve the problem totally, but which was a 25 to 30% effect. So I raised my hand and pointed out that no, they're not experimental. They're an extrapolation. He did get a little red in the face and that was so that the functions and so forth. I gave him a copy of our paper for but it's just an illustration that the books are never totally closed. Sometimes you do need new physics with strange consequences, as the quantum mechanics did, as Walter did. Or sometimes it's just doing things more carefully. Now, on a very simple basis, I want to first point out, use the first part of this to illustrate why the standard community is very dubious. This is John's first miracle about the high tunneling rates that you need for the fusion rates. If you look at center mass energy of 140 in an electron, that's like 300 degrees Kelvin per temperature, and you plug into the gamma factor here, you find that the tunneling probability is 10 to the minus 2,730 in room temperature. And we plug in the astrophysicals, the fashion, and things like that, you get terrific fusion rates. I sort of invented a very simple model that we do analytic calculations because most of the screening models are difficult enough that you have to do numerical calculations and use a little side of the physics. The model, my shielding model, ends up with just a shifted Coulomb potential. You don't have to worry about an exponential fall off as on the screen or divided or other forms of shielding. And if you conceptualize a concentric shell of negative charge, equal opposite to that of the nucleon of the proton, say equal 1 electron charge, then you get this potential. You can do the calculation analytically. And just for illustration, if we look again at 1/40th electron volt, room temperature, with shielding at 1 angstrom, which is non-important shielding, you pick up 2,616 orders of magnitude. The tunnel coefficient is now 10 to the minus 114, still minuscule. The only reason I point this out is just to show you the tremendous sensitivity of the tunneling coefficient. It still is not enough to even account for the general field. I think, in all fairness, we have to be critical of ourselves, perhaps even before the outside community is critical of us, not in a brother to a brother way, but in a way where we help each other, raise raise questions and doubt. I have tremendous respect for Julian Schroeder. I followed a lot of his work because I worked on nuclear electromagnetic pulse, and he wrote the premier papers in synchrotron radiation. And to his credit, he wrote one that I used as gospel for myself. I used it as gospel about 10 years ago. It was written about 15 or 20 years. And he wrote another paper some 20 years later on the very same subject, pointing out errors that he made in the previous paper. I think you find that in very few science. You found in old days Maxwell did things like that. I think, unfortunately, I would like to have come to an opposite conclusion. There's some serious errors in Schroeder's paper. He basically has a lattice vibration model, and he modifies the photon potential due to zero-point oscillations in the lattice. Basically, his increment in potential should be smaller than the potential for his analysis. He finds that it's bigger, and that should raise a red flag, and so it gives him a much bigger effect. Basically, he's narrowing down the photon potential, which I showed you with the screen. There's no mystery there. There are some other problems, even if you overlook that one, you can catch that problem. And his first paper, he was looking at DD fusion, and his subsequent two papers, he looked at proton plus deuterium fusion. And part of the problem in the DD fusion paper, widely in our voting letter, he didn't answer, was that your maximum photon frequency is about 10 to the 13th per second. So your photon emission time is about 10 to the 13 seconds. But the decay channels for DD fusion are like about 10 to the 22 seconds, and they would decay much faster than the photons do anything. Also, there's another problem, which is generic for all the solutions that allow for DD fusion with the dominance of the tritium channel. So it's not just a problem with Schroeder, who predicts very large tritium rates. Even with DEDX, the loss of energy of the tritium removed through the lattice, one can expect the MeV tritium, so orthodox wood starts out at 3 MeV, and I think we can go down to the high KeV and still have the problem. We have the subsequent reaction, deuterium plus tritium, giving you helium-4 at 3.5 MeV and a 14 MeV neutron, which no one has ever detected. I think that's a problem we need to worry about. There were some very interesting and initially very appealing solutions related to what I'll call exotic chemistry. Had they been right, they would eliminate the basis for John's miracle. Because with exotic chemistry, you basically get the energy from more deeply bound electron levels rather than from any nuclear process. And so I took them very seriously in the calculations, and in all due respect to authors of these theories, I don't think they're right. I'll try to find some reasons why. One that's an extreme one is the deep Dirac level model, which was recently published, maybe in the issue just before the last issue of Fusion Technology, by Mallory and Vadra. And they got a 500 keV, half an MeV binding energy with an orbit as high as 5 Fermi. And this hydrogen atom, deuterium atom, is almost like a neutron. It wouldn't make a difference within its hydrogen or deuterium, so it also could maybe explain the Blackwater results because it's basically chemical, actually, the energy flowing down. Now, as my colleagues and I worked out, the basic problem is that they looked at the irregular solution. In books you'll find is basically the regular solution of the Dirac equation, because basically basically is simplified to 0 nuclear radius. They can't accept the irregular solution as it goes up. For these people, they cut off the nuclear radius, so they didn't have that problem, and just threw out the regular solution. That's what gave them the solution. Well, the general solution is the sum of the regular and irregular solutions, and then meet the boundary conditions of the regular quantity. It makes almost homogeneous. So basically, the fundamental approach is flawed. Let's assume that we're right. Even if it were right, if you had a electron orbit radius of 5 Fermis, you don't get around the nuclear ash problem, because at that radius, it's 50 times smaller than mnemonic orbits. And muon catalyzed fusion of 250 Fermis, and such tight the atoms did exist on collision to produce a much higher fusion rate than muon catalyzed fusion. And you still have to account for nuclear ash. There are many exotic chemistry solutions. I'll just touch on one more that was first presented by Baruch in 1990, a little variation by Brzezinski in 1990, and another one by Professor Jean-Pierre Vigier in 1992. Again, my deference to these gentlemen, I don't think I'm going to leave with them. I've followed Baruch's work for decades. He has top-notch theoretical high-energy work. I followed Vigier's work since I was a graduate student, and I have tremendous respect for him. They get a 50 kV instead of a 500 kV binding energy. The model is basically one electron exactly, precisely between either 2 protons or 2 deuterons. They do Baruch and Vigier or Sommerfeld analysis and find that you have a very tight orbit. I think the initial starting point is flawed. It's an unstable situation. I think also, even if it weren't flawed, I always think, well, maybe we'll look something. Quantum mechanics really asked us a lot when they said, accelerated charge atoms don't radiate. So maybe sometimes we have to allow something to see through other flaws. And the other flaws are that one of the calculations so far presented is not enough history. That's fine for protons and deuterons. They're heavy enough that the velocity is going to become relativistic. It's not fine for the electrons. They seem to be stationary, which violates the uncertainty principle in quantum mechanics. You have to let the electron go around because it's so light. I'm sorry, thank you. It's so light that you do have to do a relativistic calculation for the electron. That hasn't been done. Now, both Baruch and Vigier pointed out that more detailed analysis would include spin-spin and spin-orbit coupling, which is short range and stronger forces. And maybe that will solve the problem. I don't know, but there's still also the problem of nuclear ash. Again, because the orbit is so tight, it's a radius of about 20 Fermis, one up to also get a lot of fusion. And you can see the nuclear ash. And for all the exotic chemistry solutions, be it Mallees, Fees, or Nettles, or any analysis, the simplest proof, which I think everyone in the world accepts, spectral lines, which should be different than the ordinary atoms, to my knowledge, in the 7th and 4th. All right, let's look at Parmenter and Lamb briefly. This is Lois Lamb, Nobel Prize winner, paper published in the National Academy of Science Proceedings. They calculated in the first paper, fusion rate of about 10 to the minus 30 per second per dB, which exceeds the Levitt naming limit of 10 to the minus 47 by 17 orders of magnitude. And Levitt naming wrote a very good and interesting paper, though I think it isn't the last word. They attributed this extra 17 orders of magnitude to the potential level of the trapping site, which was neglected by the game. And the element, by the way, is reached by them and is gotten by them when they leave the trapping site. So I think the analysis is very similar. And also, I took in mind that the Leggett main argument against the effectiveness of shielding is an equilibrium argument. Cold fusion is not necessarily an equilibrium process. In the second parliamentary lamp paper, they further circumvent the Leggett game limit because they consider that even though the electrons close in to the nuclei, I think properly can only have their free mass assigned. They make a strong argument that a larger effective mass has to be used for things that are further out. And so they gain a total factor of 10 to the 24th. And they argue that the many electrons in the metal provide considerably more effective shielding of the deuteron than the single electron in the deuterium atom, or the case in the molecule. Now, in all fairness, we must point out that Richard Garland, I have a lot of respect for, and others argue that large electron effective mass is not capable of allowing deuterons to approach closely. So it's negative on shielding, it's negative on cold fusion, it's negative on effective mass. And he basically says, he leaves the door open and doesn't close it totally. The experiments will surely show that a cold nuclear fusion is taking place. If so, it will teach us much besides humility and may indeed provide insight into significant geophysical puzzles. I'm just going to quickly read the parliamentary lamp said in their paper. The calculations reported here may be viewed by some as a vain attempt on part of the authors to revive a dead horse. In view of the recent outpouring of negative publicity concerning cold fusion and the sometimes vicious attacks on its proponents. And for them, the low neutron levels, Jones levels, can be explained without invoking any physics more esoteric than that of screening the positive charges by conventional electrons. There was a similar situation in semiconductor physics in the early days to that which we find in cold fusion. And I'll just present this one slide, thoughts of great physics, to sort of sum up the feelings of the time, because experiments couldn't be reproduced, people couldn't understand why the effects occurred. I understand plants were built after we got things going, and the whole plant turned out not to operate for some variable that was in control. Said, one shouldn't work on semiconductors. That is a filthy mess. Who knows whether they really exist? Let's see where we are today with the semiconductor industry. Two more view graphs. One's on the question of reproducibility. I think it's quite unfair to label a science or neophyte science as pathological because of lack of replicability or reproducibility. There are many phenomena that respectable scientists and different objects of scientific inquiry. Weather's one, lightning's another, earthquakes, sunspots, solar storms. Just point out something about solar storms because you're probably not familiar with them. The cycle comes about every 11 years, and utilities in the United States have been around for about 100 years. And certain transformers, when there's a lot of solar storm, a lot of sunspot activity, go crazy, they start shaking. Sometimes they break up. Big expensive transformers just go out. And a utility engineer noticed this correlation and found that it was so good that he stuck his neck out and said solar storms, sunspots on the sun are wrecking these transformers. Well, he was basically labeled as crazy. I'm not sure if he lost his job, but he certainly was muzzled. turns out he was right on. It's exactly due to the sunspots and the solar wind and its coupling with the long east-west transmission line. So we have to be careful who we label crazy and who we label pathological. We also have to listen to the other side. I'd say in conclusion that the issues raised by John Hussein have not yet been fully answered, in my opinion. I think the issues raised by him need to be answered. Of the three miracles, for me, the most important miracle to answer is miracle 3. Where are the problems? The exotic chemistry solutions are appealing because they appear to completely eliminate this miracle. However, as I pointed out earlier, they really don't know how to see that. Miracles 1 and 2 also need to be answered, but I think they're really in a different category. I think with the specific historical exceptions that I pointed out, they weaken John's attempt to discredit cold fusion by reliance on conventional disagreement with what's being seen experimentally in these cases. We do need to understand better why the atomic coefficient is so exceptionally high, why the branching ratio is so far from unity, why the secondary reaction to deuterium is driven is not occurring. In my opinion, no theory yet answers these points. And regardless of the nature of the mechanism, whether it be exotic nuclear or exotic chemistry, I would give reproducibility of some effect on neutron elements, the trillion work that Safe Fitzwill has reported, or other people have reported, that might be manufacturing these ideas. The highest priority to be done by an independent laboratory, and I think then we get the credibility of the mainstream scientific community. And I think in this day and age where the economics of all the countries are bad, that would really help us, and I think would make a big difference. Thank you.
I'm going to once again take a chairman's prerogative to make a statement. In other fields at other conferences, a lot of internal policing is done, and it's done through the way of accepting and rejecting papers and canning some speakers, giving other speakers lots of time somewhere. In this community, in the theory end, largely because folks are still looking around and thinking, we've been very accepting. And this is sort of one of the first talks. Preparati gave one earlier, reviewing various theories, giving pluses and minuses. And it's probably a good thing for our community to do a little bit more soul-searching. As theories get stronger, they'll stand up better to the soul-searching. This paper will undoubtedly draw a firestorm of questions and comments. And I'm going to propose the following solution. I'm going to accept probably 2 or 3 rather short questions, and then I'm going to allow folks to stay or leave, and I think we'll continue the conversation, which will undoubtedly go on for about half an hour. Julian,
let me comment on some points you raised first. I'm in agreement, basically, that when you have a new science, that you do have to be a little bit more forgiving and open, because you may just be rejecting the thing that is important. So I certainly concur with Peter on that point. Also, I would commend the scientists present at this conference, and the only other one that I've ever attended was the Provo one. I think the courtesy and respect that I've seen to the non-believers, to Doug Morrison, to John Hussein, is far better and far greater than I've seen at superconductivity conferences and elsewhere. And I hope that continues. I think as gadflies of cold fusion, if they don't mind being called that, that's not inflammatory, they serve a useful purpose, and I'm happy to see that they're working on
Having appreciated in the historical analysis, in particular the sources that are related to my work and my collaborators' work during the last 4 years.
I'm not quite sure what you mean, but let's not get into analysis.
Okay, let me explain to you. Sources means pieces of scientific evidence that have been presented. You have made a list, and then you have selected them in a certain way to certain points. But the historian, you have taken the historian point of view, but the historian has to have the intellectual honesty to clarify why certain sources which are relevant to this work have been neglected and for what reasons.
Good question.
I have not purposely neglected any of your work resources, Giuliano, or anyone else's. First, when you talk, there's a limit to the amount of time. I spent maybe about 12 minutes of my talk or so on historical background. I don't want to get into debate now, but I do present your... I do present, Giuliano, any aspersions that you cast on my integrity. I have tried to be fair to everybody. I think the people who know me know that I have the highest integrity, and I don't think that is very honest. That's enough.
You should have qualified. You should have qualified why you take in explaining the famous miracles of Isenga, which we have already discussed a lot. Why do you think that the explanation, or at least the progress we have made, all of us, in a sort of collective way, because there is essentially a lot of interaction, a lot of exchange. We have taken a lot of work, down, and we have looked at it, and we have discussed it, and we have totally neglected it, because I believe we have made a lot of progress in the last 2 or 3 years to precisely give an explanation to the convention, general convention, then accepted picture, an explanation why things are changing, why there is a shift of paradigm, and you start with Napoleonic theories, and then you don't realize that just under your eyes there are things happening, and you are acting as if this thing didn't exist.
Hey, Giuliano, thank you for your comment. I think
I must reply.
Mario, as chair, I'm going to come down with my iron fist one more time. What I'd like to do, if possible, this conversation is guaranteed to drag on for a while. And, for the folks who would like to break for lunch, I think it's probably okay to begin drifting. Let me let Mario respond and then I'll see your questions.
Giuliano, you asked. Would you be quiet, please, now? It's my turn. Please sit down and I'll answer you. Now, I didn't think that you wanted me to stand up here and say this, but you'll see it in writing. I've gone through your work very carefully. I'm very familiar with your work. I think there are 3 categories of error that can be made in scientific theoretical paper: numeric, algebraic, and conceptual. And I have found all 3 in your work is to be documented and writing. That's my answer to you.
Let me ask, I just want to ask.
Hold on, let's let the air settle here for a moment. Let me make a comment that in various scientific discourses, somebody proposes a theory, documents it, writes it down, and somebody makes comments, documents and writes it down. And it's probably best in this field to continue this particular discussion in documents of one sort or another that could be responded at leisure. Sort of a difficulty that folks have is when they get feedback in real time, and it gets their anger up, including the Giuliano and others. What I'd like to do is hear it to see if we can maintain a friendly and collegial atmosphere as much as possible, and then try to take these issues and address them at a leisure where we can be more level-headed about it.
Sure, just a quick question. First of all, Dr. Nerwitz, I was very fond of your talk. I thought it was excellent. But I want to ask you a question. Do you not think that you have been too kind, perhaps, to critics, such as Dr. Huizinga, Professor Morrison, and so forth, Dr. Morrison, and so forth, from the following perspective? They have introduced the term pathological theory, which I noted you put only at the end. They've introduced that into the debate. They have also introduced another concept, which is implicit, I think, in your whole talk, and that is, if we do not have an explanation, therefore ignore all the results, all the data, it's all nonsense. Do you not think that they have been unduly harsh in persisting year after year to call diligent workers pathological scientists? And one other thing,
Gene, a question.
I think that some people have indeed been unduly hard, and I think it's reprehensible. Nevertheless, one should listen to the parts that they have said that require answering, and this is what I've emphasized. There are many examples, right to this day, of things that are experimentally accepted that have no theoretical answers. We could go over them and over them. Nevertheless, I think that because these people represent not just the majority view of the scientific community, but perhaps 90%, that despite any ill manners that they show, we should not return that in kind, and we should hear them out in a courteous, civil way, unlike the way Giuliano respond.
All right, let's maintain collegiality. One more question.
I think it's very striking about your comments about superconductivity and so forth. It had to do with, identifying new phenomena that reverse the paradigm. I put it to you that in the case of hydrogen and metals, there's an accumulating body of information that mainly related to where things are located, and it's diffusivity and transport that is something that it really is not being considered by the naysayers, and in lots of cases by the positive sayers as well. And that some interjection, I would think that some interjection about the role of hydrogen and metals in the analysis would be beneficial.
I'm not sure what it was to us.
Well, you neglected. I mean, in some of the things that Giuliano was saying when he's talking, he may have errors, but yes, and he has.
The duty, the scientific community,
Okay.
to further their
I
knowledge.
was saying-
Because ignoring it is an act of contempt.
Just take a second.
They will not be ignored.
Giuliano and I have both pointed out something that I think is rather important and has bearing on what you said, which is that when you achieve full loading or close to full loading, there's the possibility of a new type of phenomenon that seems to have been observed now.
Scott,
The
to
reason
the point, please.
the reason I point this out is that Giuliano may have made a mistake, but I think he does have vision. And the recognition of the phenomenon, hydrogen and metals does weird stuff.
Scott, to the point.
Well, that's the comment.
Wait a minute, let those go to lunch, you wish, let
Let Mario respond, and let's have a round of applause for him.
I certainly agree with Scott that there are a lot of anomalies of hydrogen in metals, in particular in palladium, because I worked in the field of superconductivity. One of the first anomalies, long before cold fusion, that I was aware of was the palladium hydride system. Palladium by itself, taken to the very lowest temperatures obtainable, under 30 degree Kelvin, below Kelvin, is not superconducting. Palladium hydride, I forget the exact number, say approximately, is superconducting at about 10 degrees Kelvin.
It's
9 degrees Kelvin. And it appears to have, well, it has experimentally an inverse isotope effect, again, which goes counter to the common understanding. So I certainly agree in the field that I know and in other areas, there are a lot of anomalies of hydride. So we don't disagree.
Just to make a note of the committee meeting, that's all I want to say.
Thank you. I think continued discussion, given a provocative paper, there's some room and time for that, I think.
I just want to make a small comment and see if there's any agreement, if so, clap or something. I think there ought to be a different arrangement in terms of penalties for people who go over and so forth. Then there's never any time for discussion or never anything. I think the time for discussion ought to be had. Quit penalizing the audience for somebody going over. Somehow we've got to resolve that, because with this assembly of experts and so forth, the very best time for many of us is the discussion. It's better than the paper.
Oh, that's all right. No, I can start it.
No, it's okay.
How much tape is in there, though?
Oh, it's got almost 2 hours from now. I'll bring another tape back later, okay?
Apparently I said, or it was understood, that I took these personally in my poem, and I was struggling to say pathological skeptics, and I couldn't remember the word pathological. I apologize, Dr. I did put Morrison in my poem, and the idea is that we can make these things hot enough, everybody's going to understand it. I owe an apology to Dr. Husenga. I called his publisher and asked his publisher if I could quote his book. He said, what I got told was, I'll call you back and let you know. I got called back and said, no, you can't quote from it. So I paraphrased it, but Dr. Husenga was never contacted and asked. He would have given me permission. I apologize to anyone who's I've been offensive to anyone, and I apologize. I'd like to say something about Dr. Morrison. He's very bright, as is Dr. Husenga. I love to talk to him. He's very knowledgeable. If these guys ever get on the side of new science, they'll put monuments to them, because they have the capability of helping us advance this new science dramatically. With that, I'd like to start my talk. And I use the 2 minutes of my time for the apologies. First slide, please. Or not slide, but transparency. Just a little fun. God made the earth in 7 creating periods. It can be replicated. The earth is unreal, and I really believe that the earth is unreal, especially in this day and age. Next slide. My name is Hal Fox. I'm editor of Fusion Facts, editor of New Energy News, co-founder and president of IC, co-founder of FRI, FDAT. They merged, became Eneco. And I've never been accused of being humble, and I'm darn proud of what we have been able to, with a lot of other people's help, and what we've been able to accomplish. My talk today is on cold nuclear fusion and enhanced energy devices. My physics professor told me many years ago, when I asked him what his doctoral thesis was, he said, my thesis was on the Edison effect. My conclusion was it had no commercial application. Now, you young guys who don't know what the Edison effect is, that's what laid the basis for all the vacuum tube technology and electronics industry. My lesson was one I'll never forget. Scientists and engineers are capable of solving this world's problems. For those who get up and tell you we can't do it, just stand there and watch, because we're going to do it. Next slide. Okay, my talk will be an opinionated businessman. I'm not a scientist. I really like the idea that we're not finding neutrons and we're not finding tritium. There's lots of excess heat, and that's good. That's the best combination for commercial use. Next slide. This is a Pons Fleischmann cell. According to an interview with Dr. Pons on the film by the Canadian Broadcasting System, he's showing some devices which he says they're working toward within a year to have something in the order of 10 kilowatts in this microwave unit. Therefore, I deem this to be commercial. Next slide. This is the light water cell. It started out with Mills did the first work. Bush Needleton have done a lot of the work on it since. They've had some very interesting results, particularly in the area of transportation. Under low current, there have been reported in the literature up more than, in little bursts or whatever, up more than 1,000%. Normally, these cells will run something like 30 to 70%, and under the best conditions, you get higher than that. I think that within a couple of years, we'll have this type of cell be able to produce 300% excess heat. That's my definition of commercial. Next one, please. This is the molten salt electrochemical cell, Liao and Liebert. It's had a great deal of difficulty in replication. It's an extremely difficult environment to work in. But here again, they're dedicated people. I think they'll solve the problem. In some states, they've had as much as 15 times the amount of energy out that they put in. Next slide, please. This is the Kucherov-Karapet-Savitonova device, gas plasma device using low pressure. That's incorrect. You're using low pressure deuterium gas. Dr. Bass, sit right up here in front, will you? Remember one of the authors of the program. One of the speakers. They've achieved as much as 500% excess heat. They've achieved temperatures up to 1,800 degrees centigrade, but not at the same time. I think as we continue with this device, we'll definitely have commercial applications. And I suggest that it will probably be a leading contender to do something in some of the aerospace industry equipment. Next, I told you this was going to be opinionated. This are capillary fusion in bronze crystals. I have some samples here if anybody wants to see what they look like. You fill it with either hydrogen or deuterium gas. It works a lot better with deuterium. The problem is there apparently, at least from the initial indications, there are significant numbers of neutrons that are given out when they put a voltage across the capillaries. Next transparency. This is Yamaguchi palladium sandwich, and here again, Dr. Huizinga has told me that I asked the speaker with Dr. Jones, what was your gentleman's name? I asked him, why doesn't BYU give something that puts out neutrons while they can measure with it? Dr. Huizinga tells me that the neutron measuring device here had about 10 to the 6th ability to measure neutrons, and that the neutron measurement has not been that well shown to be in effect. At any rate, in the Yamaguchi work, it's been very interesting. It definitely does give a lot of excess heat. It's been explained as the release of the deuterium. For commercial work, I do not see applications for it, but I may be confused. If I ever give a negative, you check me out and find out how quick I can become wrong. Next. Okay, hot fusion will be commercial within 20 years. I believe that the engineers in hot fusion will be able to solve the problem. I think there's no question that they can. However, they've been saying this for 40 years. Maybe it's time we get along with try some other types of nuclear reaction or energy reactions. Next one, please. Now I'm going to take you into the real wild blue yonder. If you think there's been people who've been pathologically skeptic about, appropriately skeptic about cold fusion, wait till you see what's going on now in tapping the energy of space. This is a device been worked on about 10 years now by a gentleman by the name of Kawara in India. He puts 1,000 watts in the drive motor and gets 2 to 3,000 watts from the output. It's based on the work done in 1831 by, I just had a mental gap. Who's the great experimentalist? Faraday. Thank you, Dr. Bacchus. Okay, next slide, please. This is the work that's being done by Inamata in Japan. He's now being funded by MIDI, so he says. This is the conceptual figure of the new machine that he will be working on. The old one was shown to get excess energy, that is more than unity output, it's a small machine, if you counted the inefficiency of the drive motor. In this case, he's trying to work out the device which will have sort of the Faraday motor on one end and the end machine generator on the other. He's worked out the equations. It's a very interesting concept. The difficulties are taking those low voltage, very high amperage currents out of the machines. Next slide. This one's really way out. I brought it to you explicitly because it is so far out. This is the Cyril machine. And he uses these magnetic rollers with magnetized rings, and in the process, he generates, or he started out to make a serial generator of energy. It levitated off the kitchen table and bounced around against the ceiling. His wife kicked him out of the house, and he made several more of them, lost several of them into space, so the story is. He ended up in jail, and he's now back dredging up some of his equipment and trying to raise funds to do something like this. Now, the interesting part of the story is he went to Edwards Air Force Base and either demonstrated or talked about it. Now, in some very apparently so reported, highly classified work is going on in Edwards Base, but been reported in some of the way out literature. They do have devices that appear to have be doing something similar to some of this to Cyril's equipment. He's not a scientist, it's not peer reviewed, but it just has something of interest for you. Next slide, next transparency. This is the S machine, Siberian Coley, that Stefan Marinoff is working with. He's trying to duplicate the work of the Methernina machine. I didn't have a good slide, but if you'll turn to the copy of the paper next to the last page, you'll see a little. The Methernina machine is one that has producing something in the order of, I think, 1,500 watts. They have a new one that's supposed to put out about 35 kilowatts. Started up by hand, it continues thereafter, and it puts out power. Next machine, please. This is Adam's permanent magnetic electric motor. He's now joined forces with Harold Aspen of England, who is a real expert in magnetic phenomena. He makes some very interesting discoveries when Harold Aspen, that is, when he's doing his PhD work in England. They allowed him to publish, they allowed him to do his thesis, but he was never able to have a peer-reviewed paper published. He's now at a joint force with Adams. Adams had a public demonstration in New Zealand here about a month ago, an invited demonstration to see his motor work. Input of 22 watts, he was sawing wood. Now I give that to you as hearsay evidence. I haven't seen it myself. Next one, please. Whoops, I missed one somewhere. Let's see what the next slide is. Oh, yeah, sorry, still out on the first page. This is a work by Ken Shoulders. This is the one I think is going to be the most competition for the excess energy found by cold fusion. Ken Shoulders was one of the engineer scientists that laid the basis for the semiconductor industry in the lithography and all the levels of equipment that it takes to make integrated circuits. Later, at SRI, he worked out the field effect, arrays of field effect transistors, which now are field effect devices, which is now just beginning to achieve some commercial potential. He went he worked with Hal Putoff, and he funded by the Church Chicken franchise funds, and for several years they worked on next generation's technology. What this device does is with a very sharp, as short of pulses you can create, like nanoseconds if you could do it. At the end of that pointed cathode, you create an electron high-density charge cluster. And these clusters flow through that device at about 1/10 the speed of light. When they hit the anode, through the output in the low there is approximately equal to the input. The charge cluster going down, through that coil of wire, you can take out additional energy as much as 30 times the input. The problem with that one is they're such dramatic little charge-intensive beasts that they charge up the circuit. It's hard to get a high pulse rate. He's designed some additional approaches that look like they will be very, very effective in having an electrical input, electrical output. The next one, please. The next one. Now, this is what the high-density charge cluster appears to be like. If you have a witness plate where we showed the anode in the previous slide, the high-density charge cluster will create either a hole or if you have a foil that's appropriate enough, you'll get these several little blasts. Now, the Hal Fox interpretation, and I want you to make sure that this is, I'm not citing, the Hal Fox interpretation of those is that each of those is a little vortex of electrons, ranging somewhere from 10 to 7, 10 to 8 electrons, and each of the small pieces, they connect together by their mutual charge, are highly dynamic, and make a ring. And in fact, the ring, if they may come out as being a very non-uniform creation, then as they go through the vacuum or low-pressure gas, they form into a nice ring by the forces involved. Now, the Coulomb effect, there's no question about it. You all know that the Coulomb effect is a static effect. The Coulomb effect, you would think, were these static, all these would blow apart. They don't blow apart, they hold together, maintain their configuration. There's been very little there's been almost nothing in the peer-reviewed literature about this technology. It's about 5 years old. It's been classified by one government department as being the most important technology after the stealth bomber for interest in the federal government. The size of those, you can see about 20 microns. They're quite consistent. I've seen photographs and such where these electron clusters have drilled through several millimeters of aluminum oxide and have not lost energy. I made some quick calculations and it appeared to take about 1,000 times as much energy to drill through that aluminum oxide as it would be to, as taken into create the electron beam, or EVs as they're called, these high-density charge clusters in the first place. At the end of my presentation, we've got a couple of minutes for questions. No questions? We'll go to the next speaker. Dr. Morrison, I apologize if I offended you last night.
No, it wasn't me, it was Tom Pastor.
Whoever I offended, I apologize.
Right, I'm afraid this talk is going to be very different from the previous one, because I'm not a businessman, and the review, I believe, in a scientific way, you should look at all data, both positive and negative. The previous talk was rather limited, it didn't seem to be positive and negative. The proceedings of the International Cold Fusion meetings are rather unsuitable, where the balance of positive and negative data is somewhat different from literature. So what I've done is take all the papers listed by date of Brits, and if you remember for Nagoya, I gave the statistics between April 89 and September 92. Now I'm taking the following year, so this is 1 year's published data, which I hope is random for both positive and negative results. Now, I think it's agreed by all that statistics of positive and null results alone do not decide. But it's an interesting introduction to the database, so no conclusions are drawn. Because very often you give this and people say, you're trying to decide all of science on the basis of statistics. Just to remind you, this was what happened in Nagoya, where all the papers, theory and experiment, and as you see, most papers experimental are null. Null means they find zero result and give an upper limit, which is lower than people claim. And this is true for excess heat, for neutrons, tritium, protons, X-rays, helium-3, helium-4. Now, let's take the new period of 1 year, where there's a total of 76 papers listed by data, of which the experimental 13 null, 10 positive, and 4 no decision. For the theory, 3 null, 20 positive, and 3 null. So, as you see, the theory is very positive. Now, my graph, John Husinger made a much nicer drawing than I did. So what I've done is added on the data. And this is the null experiments, and you can see the null dominate, but there seems to be an increase in the number of published papers in this period of 1 year. Taking the statistical summary, there are new classifications, like fractal fusion, using a laser. There's a transmutation, there's a positive paper, using hydrogen, but not finding deuterium as 1. Now, many people, in fact, who use deuterium say they don't have hydrogen. I don't have this number. For Mossbauer effect, there's one says it's not the Mossbauer, despite Peter Hagelstein. For black holes, there's one paper say they have it. I don't know the number that haven't found black holes, but very few people write down they have not found black holes. For the gammas, there's 2 zeros. Now, taking the previous classifications, which is more common, for helium-3, 3 null, 1 positive, helium-4, 1 null, 3 positive. X-rays 0, 0, protons 1, 0, tritium 6, 2, neutrons 12, 9. Now, since people say these numbers don't mean anything, when I show you that excess heat has 3 null and 10 positive, this you will continue to believe don't mean anything. There's not. There's a special business where you have excess heat with no input, known as life after death, and there are 2 such papers. And remarkably enough, both of them observed heat being constant or rising when there's no heat input. The first was by Dr. Matsumoto, and the second by Dr. Fleischmann and Pons.
That's incorrect. Gauzy did that at the very first meeting.
Oh, I'm sorry.
Gauzy had heat at the very first meeting.
Gauzy, so there's 3 then. But this is a 12-month period, and it's published referees papers. What happened before, I'm not considering. I'm taking a 12-month period up until just a couple of months ago. Okay? What do we expect to see? Now, in previous meetings, between 89 and 92, we had conclusion and ideas for future work. It is not easy to find out what people said in previous meetings, because I'm accustomed to going to meetings when you have a summary speaker. And the summary speaker works very hard, an intelligent, well-versed guy, and then he gives a summary of all the things he's heard. That didn't happen. There are round tables to terminate meetings, but these round tables have not been published. So it is very hard to find out what people say. Looking from my own notes, what they've said roughly is, do good experiments. Secondly, a theory that fits all, in inverted commas, data, and then to make a working model to prove cold fusion. And these are my 3 main topics. Firstly, do good experiments. The field should be mature now, since it's 4.5 years since the famous Fleischmann and Pons press conference in '89. 10 years since Fleischmann and Pons started working, because it said we'd been working 5.5 years beforehand, 5.5 beforehand, means 10 years, September '83, when they claimed they've started. Many groups are now well funded, so it should be possible to do good experiments with good apparatus. Do not use poor equipment, like borium trifluoride counters, you know, the health physics thing. Do not use X-rays, please. Instead, use detectors that discriminate, where you get the spectrum of X-rays, like the 21 keV from palladium. Steve Jones is offering this free to people who want to. What is remarkable is how few have accepted this free offer. For neutrons, I think don't just say we have a neutron. Measure the energy spectrum and try and find the 2.45 MeV neutron. And the Turing group, in fact, has found this. Look for correlations. It is not enough to measure only one effect. Like we measure only neutrons, we measure only excess heat. What again and again people at previous meetings have said, all the way back last year, the year before, oh, Dr. Ikegemis comes in, are you going to remove my microphone and battery again?
Not this time.
Not this time, good. Look for correlations. I almost refused the microphone and battery, but you weren't here, so I accepted. It is not enough to measure only one effect, neutrons only. If you want correlations, everyone has said you need a correlation, it's not enough. So you have excess heat with several types of nuclear ash, neutrons, protons, X-rays, tritium, helium-3. It is usually, in the past, it was found that better experiments find, when they do look for correlation, they find 0, no effects. And I would remind you of what Martin Fleischmann said, 1992 must be the year of mass spectroscopy. Sorry, this mass. It was quite intentional. I thought we should use pen ink instead of washboard. Oh well.
That's why passing it, by the way.
Is it? I'm sorry, yes. Thank you. 4, do use adequate instrumentation. I mean, to have your little test tube with 1 thermometer in is simply not enough to study the temperature and heat flow. And this particularly applies to the Fleischmann and Pons experiment, when they claim life after death. But they should measure, have thermometers measuring everywhere, and they don't do this. Also, you need to make checks. And you need to have several possibilities of many measuring devices. You also need a good, fast recording system for the current and voltage to check whether there are any oscillations, any fluctuations. As Fleischmann and Pons, they're boiling off the water very vigorous, you have lots of things. And they only record it every 300 seconds for an event lasting a total time of 600 seconds. And simply, this is not good enough to derive any physics conclusions. You should design experiments to avoid problems and controversy. Open cell calorimetry is poor. You need a vast number of assumptions, and like, for example, what is the percentage recombination? is lithium carried out of the cell with the gas? What percentage of water droplets are blown or carried out of the cell? This is very important for excess heat, because if instead of having gas going off, you have water going off, then you heat of recombination. It's not good. By the way, how much time are you giving me a warning?
You've got another 16 minutes.
16. Are you sure?
I'm sorry, excuse me.
I agree, I accept. I'll slow down then. Instead of assumptions, use closed cells. And I think particularly the best type of physics where you avoid all the calculation worries is to use the Wheatstone bridge type of null method. I mean, there you vary things, but you measure zero current. The same sort of thing can be done in calorimetry, where you have a series of cells and then 3 water baths. So if the ambient temperature is 20, the first water bath 30, the next 35, the next 40. You put your cell in the middle, and if your cell starts getting out excess heat, then you reduce the heating, so you keep the same temperature. Then there's no corrections. Closed cell, you don't have to add little bits of water and like that. You're not worried about boil off. You're not worried about losing lithium. Because if you boil off all the time, the General Electric people have found out the lithium goes away. And then you add only pure DTO, you don't add lithium. So the amount of lithium decreases, and your resistance changes, and you can get very strange effects which are not calculated. So open cells and a new method are important. 6, try to prove yourself wrong. The easiest person to deceive is yourself. If you say no recombination, then you should try and prove it experimentally and not do it by calculation, by saying, oh, I do a nonlinear regression analysis and the K prime here and the K prime here agrees, therefore there's no recombination. This is not good experimental technique. For example, one way to see whether it's recombination or not is to vary the separation of the anode and cathode. And Lee Hansen at Brigham Young University, in fact, has done this. And he found that when he had the Fleischmann-Pons prescription, he got excess heat. Then when he separated the cathode and the anode, the excess heat vanished, which made him think that perhaps it might be a recombination, but the two gases boil up vigorously, and they're very, very close together. Then just to check, he blew in nitrogen gas heat on the foot, which blew out the things before they could recombine. And again, the excess heat vanished. So one strongly suspects that if you use the Fleischmann-Pons method with a very, very small piece of palladium and the anode very close, there's probably some recombination. Do it experimentally. So, and the question is the heat loss from the cell, is it 100% conduction, which is Newton's law of cooling, as I said in April 89, where they put in a term which is the difference in temperature to the power 1, or is it 100% radiation, Stefan's law, temperature to the power 4. And this was after April 89, from 1990 onwards, they've changed to say this. One should do experiments to measure this. One should vary the condition. One should put in conduction. One should try and change things to find out experimentally instead of using a nonlinear regression analysis. As far as I know, only one group has used nonlinear regression analysis, sorry, 2. General Electric also did a nonlinear regression analysis and found the calculation was bad, in error, and there were mistakes in it, and you couldn't decide whether it was excess heat or not. Number 7, you should do experiments to test theory. To give you an example, Schwinger says that the basic fusion reaction is a proton and a deuteron, which is dominant, giving helium-3. Therefore, I'm astonished, although he said this 4 years ago, no one has tried measuring excess heat where you vary in the ratio of normal water to deuterated water from 1, 25, 50, 20. This is a very simple experiment. It's amazing in 4 years, no one has tried to test Schwinger's theory. I mean, people say he's a Nobel Prize winner, he loves cold fusion, it's great. Test it experimentally. And then you look for helium-3 and excess heat. Theory. There are some things that should be explained in theory. First and foremost, the great problem is the separation of DD. Normally, deuterium gas, deuterium liquid is 0.7 angstroms. Inside the palladium crystal lattice, the separation normally is 0.285 octahedral. With great effort, for example, ion implantation, you can get it up, and then you get technically 1.74. These two numbers are appreciably greater than that, and this is a fundamental problem of cold fusion. I mean, it's a factor of 10 to the 50th we're worrying about. In other words, deuterium nuclei are further apart when you push into deuterium. It goes the wrong way by putting the palladium. It's a mistake. Now, there are tens of thousands of papers, books, etc., on hydrogen, deuterium, and palladium. There's an enormous literature. One should read it. And the data, all this data are consistent, and there's a good unifying theory. The effective medium theory explains all the data. You check it with scattering with neutrons, putting in muons, you put in polarized muons, and you observe the decay of the polarized muon, everything works. So cold fusion miracle number 1 is how on earth do you reduce the separation? And at this value, the probability is 10 to the minus 64 muons fusions per second. Or if you have a solar mass of deuterium, you have 1 per second at normal density and pressure. If cold fusion is fusion, then the next theoretical question is, if you observe it with DD, you should not observe with 8H. I mean, the cross-section is measurable, 10 to the minus 47 centimeters squared. So in other words, heavy water should give fusion, and normal water should not give fusion. So H2 is a control, if cold fusion is fusion. And many people, Fleischmann and Paul and others, found it with D2O, not with H2O. And in Nagoya last year, 5 groups reported excess heat with H2O, and we'll hear more later. Now, to some this seems a contradiction, that it's not fusion. Maybe it is quantum chemistry, it's entirely different, as VHS says. So this is cold fusion miracle number 2. Thirdly, or secondly, if it is fusion, you should observe nuclear ash. 1 watt should give 10 to the 12th per second of these things, and 10 to the 7th per second of helium-4 and gamma. These numbers are not observed. This is cold fusion miracle number 3. Also, the ratios, like T to N, should be 1, but experimentally people claim 10 to the 4th to 10 to the 8th. This is cold fusion miracle number 4, which theory should explain. Just to remind you, if you look at the Como Conference proceedings, the 2nd annual cold fusion conference, they reported on the cross-section rate, and as you can see this in a log scale, the cross-section is going down, down, down. I mean, this is the barrier penetration factor, which drops like a bomb. Here's ratio of tritium to proton, 1 to even 3. This is the ratio of these two reactions. It's charge symmetry, and it's exactly 1 when they're as far as you go. And there's no sign of any variation. Helium-4 is down a factor of 10 to the 7th, so weak interaction, you have problems with spin and parity, and it's 10 to the minus 7. Muon-catalyzed fusion is at 0 energy. I mean, muon-catalyzed fusion's value is 0 here, or it's infinity down there, and gives exactly the same number as Steve Jones will tell you. And then there's a great problem, the reaction time is 10 to the minus 20, and the lattice relaxation time is 10 to the minus 10. Now, let us now look at the theory, and as I said, during this 12-month period there were lots of theories. Gerald Venn, for example, says the new unified field theory, and this corresponds to the Earth movements with respect to the vacuum of space. And the best results are obtained at 10 in the morning, 11 in the morning, or at noon. I'm afraid I've missed it for today. Peter Hagelstein, well, he has coherent and semi-coherent neutron transfer with increased phonon coupling under some conditions will give gamma. We heard this morning. Dr. Matsumoto said there's a new elementary particle, the eton, which gives dineutrons and higher neutron assemblies, like quadrineutrons. This gives gravity decays and transmutations. Mendes said as ergodic motion, there are 3 bodies collisions which dominate, especially DDE minus. Now, I don't know the cross-section for that, but I know that in the sun for PP electron, it's very, very low. Dr. Bokris said that high fugacity, as Fleischmann and Pons have said, 10 to the 26 atoms, and it's a high fugacity at great pressure that the deuteron captures the electron and explains cold fusion. Dr. Matsumoto has another theory, which is called the NATO theory of neutron clusters, which then collapse and give you black holes. Dr. Schwarz has a quasi-one-dimensional model of loading, and the crystal structure is important, so defects, dislocation, shape, and Dr. Bokris is happy that small surface features such as spikes are important. Dr. Yazoo is a fractal fusion and cracks with cold fusion. Dr. Fisher said it's polyneutrons, about 6 neutrons he says, much more than some of the others. And Dr. Yang says the deuteron captures E minus, gives a deuteron and a dineutron, and this explains the neutron bursts, which Steve has just withdrawn. Helium-3 with neutron, strontium gamma, excess heat, and a few neutrons. By the way, these letters tell you where it's published. Like FT means it was published in fusion technology. 5 minutes? Oh, I thought you were 35 minutes. All right, let's try. Dr. Cefalini said it's binuclear atoms, DDEE, capture thermal neutrons. This tritium enriched neutron burst. Matsumoto again has a double ion explains, which explains the warming for 3 hours after death. This could be the explanation of the life after death observed by Fleischmann and Pons. Dr. Takahashi says high loadings is 3-body and 4-body fusion, very small cross-section. Branchi says collective effects are ruled out. Seems to be against Dr. Preparata. But the effective masses are very high, explained. I thought these were theory. Lowe says densely coupled plasmas. Stoppini says it's superconductivity, and you should work at less than 11 degrees Kelvin. Dr. Hora says it's dense plasma, like preparator with transmutation by neutron swapping. Neutron swapping is not in preparator though. And palladium should give you ruthenium. Dr. Filimov says deuterium soliton coherent with palladium anti-soliton. Now, soliton I know what it is, but anti-soliton is new to me. And when he gives practical advice, you should coat your electrodes with black palladium. Dr. Lipson said it's supercondensate, and he says that the fractal mechanism is improbable. Dr. Chatterjee said it's stochastic electron accumulation. Dr. Gammon says it's negative Joule-Thomson effect. Dr. Drenov says it's ampere force, and I'm reviewing a book by him, which is a very remarkable book called Newton versus Einstein, but very strange book. Dr. Hagelstein, as you heard, is Newton transfer of 3 phonons. Dr. Ichimaro is coherent plasmas, same way as Dr. Preparator, but he gets 1 to 2 fusions per year per square cubic centimeters, not very well. There was a slight discussion between Dr. Preparator and myself this morning, so I will quote, "We have an article from an Italian magazine where Preparator and Del Guici describe the theory of long-range effects in water and relate this to both cold fusion and homeopathic. This is the Benveniste claims that water is memory, and even though you dilute it, the memory keeps on," which seems different to what was said this morning. Now, notice there's a widespread of journals, and it's not just one journal, it's not just fusion technology, which is 10 publications, about half, and physics letters A, which is 2. Now, the other question, how to find it, question is, when do you start on getting a working device for cold fusion? Dr. Fox, a few minutes ago, said in 20 years' time. Last month, Dr. Pond said that the year 2000 it should be a household power plant. In other words, a delay of 6 years. So we should write Fox, 20 years is 6 years. In 1992, Dr. Fleischmann predicted there'd be a 10 to 20 kilowatt plant for the household by the end of 1993. In other words, in 1 year's time. So we have 1 more month or less than 1 month to go to see how his prediction works out. Also, in July 1989, Dr. Pond said he had already a working unit, so the delay was 0 years. It couldn't take care of the family's electrical needs, but it certainly could provide them with hot water year-round, said Pond. Simply put, in its current form, it could provide boiling water for a cup of tea. Now, you may not believe this is right, but this is the actual thing, and if anyone is particularly anxious, I have it in a very nice color, where you can read the quotations. I have more copies than this that I'll make available later. Conclusions. Firstly, no conclusions are being presented. Everyone will conclude for themselves. Are the cold fusion results consistent? If you have cold fusion in D2O and H2O, is the tritium to neutron ratio 1, or is it the ratio of 10 to the 4th to 10 to the 9th, as some claim? Do we have transmutations, black holes, biology? I mean, you know, there's a Nobel Prize, the Ig Nobel Prize this year was awarded to Dr. Kervin, I think his name was, who had written a book saying that cold fusion explains the production of calcium in chickens' eggs. There's a wide variety of theories. Can they all be correct simultaneously? And lastly, when can we have a cup of tea? Thank you.
Dr. Morrison is right articulate, and I'll add entertaining. A couple of questions. Yes, sir.
My first question would be, what's wrong with a couple of scientists working hard and trying to baby up ridiculously low fusion rates, -80 or something like that, see under what conditions and how we can have some increase of that. You see, some increase that we found. So is it right for us to refuse them? Or should we honor them as heroes who fight against almost impossible odds you see. You know, maybe you should turn around and start helping them. You see, of course, criticism is also helpful, but it's not only helpful when it denaturates in the rigidity. Therefore, I suggest that you rethink this First of all, one thing should humble you, and that's the fact that now you have to concede that there is excess heat. That means that even mainstream classical physics tells you that there are some elements of excess heat which have to be there. And so,
thank you very much.
Suspecting these people of not having anything and producing contrary results was unfair.
May I answer that?
Yes, please.
I mean, it is not, you said almost impossible. I think the number is something like 10 to the minus 50, which is pretty far. Secondly, they have improved things. I mean, initially, when they had their press conference, they said 1 watt in, 4 watts out. A few days later, they said 1 watt in, 10 watts out. Here, they say 1 watt in, 10 to 15 watts out. Then they said 1 watt in, 25 watts out. Then they said 1 watt in, 100 watts out. 1 year later, they published a paper, and they had 28 experiments. 27 of the 28 were less than 100% increase. 1 watt in, 1 watt, or less than that. And only one was more than 100% increase. And that was 102, and the current was 1 milliamp per square centimeter, which means the loading was negligible.
Compare that with hot fusion, where they've been given $20 million.
I have tried to explain this variability and
Dr. Kim next.
Successful at it.
Dr. Bush, you're out of line. Dr. Kim.
I'd like to discuss with you detail later, but as far as extrapolating cross-section to threshold energy, I think we have to wait until data point appears there, although that's the electrical experiment.
Cold nuclear fusion,
No, DD fusion extrapolation to threshold.
But Steve Jones does that all the time with cold catalyzed fusion.
No, the real measurement, beam experiment measurement, otherwise. I think you should wait until data point is taken below, currently it's, I think 6 kV lab. And there are theoretical ground to say that the gamma factor may be too crude approximation. I think you have to be more open-minded after the data comes in below 3 kV.
You're not talking about the branching ratio.
You had a question. This will be the last question. Make it a question and not a lecture.
Don't you think that this fight between skeptics and proponents of cold fusion should be fought more in the realm of philosophy of science and experimental design than, I guess, pettifogging problems with instrumentation?
Pettifogging?
Well,
pettifogging?
Any comment? Thank you very much, Dr. Morris, for your appreciation. Gene Maloff is our next speaker. Gene has written one of the most balanced books, in my opinion, about cold fusion. Has probably done more to keep people interested in cold fusion, and we welcome Gene Maloff for the next 20 minutes to give his paper.
Well, Dr. Marson has given us a lot of reasons why to disbelieve in cold fusion, and I'll just give you one reason why we should probably believe it. The Earth, among other things. I guess with Peter Hagelstein, I'll state in advance that I looked at the evidence for cold fusion, and I accept that whatever the theoretical explanation turns out to be of this phenomenon of excess heat and nuclear products and nuclear transmutations at various levels, it is real. And I will also state that I believe that cold fusion will help us to explore the cosmos, and it will help us to explore the cosmos because there's lots of water in the cosmos, and there's lots of water on Earth. Anyway, that was my second slide, which turned out to be a little commentary maybe on what Dr. Morrison said. But this is what I want to talk about. I want to talk about the implications for space technology. Many of us in the space technology field, as I have, have been more recently cold fusion, as many of you know, are fascinated by the planet Mars, and we would love to go someday to explore Mars, find out whether there ever has been life, whether there might still be life, and so forth. So that is kind of the vision. God, the colors aren't coming out very well. This is an amazing experiment. The colored slide coming out, or maybe my eyes are deceiving. Is that color there? Wow. Oh, is there maybe this is a filter? No, I can see the colors here. This is an unusual experiment. Amazing. I think that one of the cold fusion effects is possibly the shift in lighting. Okay. It costs a lot to get into space today. That's one of the main problems of space travel. It costs about $15,000 to $25,000 a kilogram to go into low Earth orbit. And it would be great if we could reduce the requirements of getting into low Earth orbit. And the general direction of my talk is going to be on ways that cold fusion might help that. Actually, the space travel, which people began to theorize about in a very serious way around the turn of the century, is roughly at the time that the Wright brothers learned how to fly, although they weren't to leave for 5 years, which is kind of a parallel to the cold fusion story. I have a recommendation for both Dr. Morrison and I think Professor Huizenga here. They should read the book by Fred C. Kelly, which is the authorized biography of the Wright brothers. There are many interesting parallels about how scientists said it couldn't be done, and they did it, and even after they did it, they weren't believed. And it took 5 years to convince the federal government that they were flying. Likewise, there were two other gentlemen at that time, turn of the century, Dr. Robert Goddard and Konstantin Tsiolkovsky in Russia, who were theorizing about space flight. And in fact, Robert Goddard actually managed to reduce his ideas about space travel later in 1926 to the world's first liquid fuel rocket. He also was ridiculed. The New York Times said he didn't have the sense laid out to high school students about physics that a rocket needed something to push against. We all know, of course, that that's wrong. But anyway, they are today experiencing the wonders of spaceflight. I hope the Hubble telescope has been repaired by this hour. Well, you might think with this fascination of space and then later cold fusion, I'm a space cadet. I did write a book on starflight, and I just quote, like the quotes of Goddard and Tsiolkovsky, to the effect that we will eventually live in space and explore the cosmos. It's as much our home as Earth is, even though Earth is, of course, a beautiful planet. To reduce the cost to orbit, the National Commission on Space came up with the idea of a national aerospace plane. They strongly advocated this. This is a single-stage to orbit craft using chemical propellants, liquid hydrogen, liquid oxygen, and there's a photo from their report. More recently, we've had the Delta Clipper X, a single-stage vehicle also that has the capability of going to orbit with one stage and perhaps returning. It's a prototype. It's just the beginning of an idea to replace the shuttle. But now let's ask ourselves if there might be another way to go into space. And I think these two quotes are very interesting. Arthur C. Clarke, in his Promise of Space, said, "Who knows how we may eventually travel to the stars?" Okay? And Robert Goddard, interestingly, thought in 1907 that it might actually require nuclear power to get into space. He had not figured out the staging concept yet. And so he thought, and this was shortly after the time of the discovery of radioactivity, and they knew that radioactivity was producing more heat by a long shot, by a millionfold in chemical reactions. So they thought in those days that maybe we would need nuclear power to get into space. He wrote that in an essay, which was rejected by Scientific American, Popular Science, Popular Astronomy, and so forth. Anyway, later on in this century, namely in the 50s, in the through 1973, we had a nuclear rocket program in the United States, in parallel with our standard chemical propulsion program. A fission reactor, basically, rover reactor was called, or NERVA. Hydrogen was passed through this solid core nuclear reactor to give an exhaust jet which produced up to 200,000 pounds thrust tested on Earth at a very high velocity, which meant it was a very efficient rocket. And later on, there were other concepts that I'll return to in suggesting ways that we might have cold fusion replace that nuclear reactor in the solid core and even in the liquid core. For you people who are not astronautics people, which I trust are many of you, the basic parameter that characterizes a rocket engine's performance is specific impulse, ISP, or the exhaust velocity divided by the acceleration of gravity. It turns out to be in units of seconds. Chemical propellants, hydrogen, oxygen, has a specific impulse of 460 seconds. The nuclear rocket, to give an example, the solid core nuclear rocket was tested and had an ISP of 845 seconds. And what's the advantage of high ISP? Higher ISP means higher exhaust velocity, and higher exhaust velocity means that this initial mass of takeoff in your rocket, ratio to your final burnout mass, can be smaller. It's not very good to have to carry a lot of propellant or have to launch from Earth with a very large high mass ratio vehicle. So we want to get high exhaust velocity or high specific impulse. Well, this chart just shows you very briefly that there are certain velocity requirements for these various missions to launch into Earth orbit and to go to Mars and so forth, in kilometers per second. They go much higher when you get into difficult missions. If you're doing it with a single stage in particular, you need very high mass ratios. It's not so bad in this column here with ISP of 460 seconds, the kind of mass ratios that you need for some of the inner solar system work. But when you really get out into the solar system, a single stage using chemical propellants is impossible to do anything with. Well, Hans and Fleischmann came along with another miracle, or three miracles, as a few of you might think. They got excess heat. I think that's been proved by now. And some of the temperatures and excess powers that are being reported now are on the order of kilowatts per cubic centimeter, and that leads me to think that it might be applicable someday in nuclear rocket propulsion. Although nuclear rocket propulsion without radiation shielding, and thus possibly much lighter. Just very briefly, I couldn't resist throwing this in, since I don't think Dr. Morrison has seen this, and you might like to see it. It's just my view of the problem. I think Steve Jones has seen this before. I don't want to spend too much time on it. You can question me later, of course. This is the cold fusion problem. Of course, Dr. Morrison and some of his colleagues think that there's nothing there. That's generally what they think, many of them. That it's pathological science, or whatever they want to call it, but there are no effects. Some people think that there might be low-level nuclear effects, such as Steve Jones at least one time did. I don't know whether he thinks that anymore. No compelling evidence, okay? So we erase Steve Jones at least from the supporter of that category. But some people do fall into that category still. Others say, well, there's just heat only, no nuclear effects. Others think of the heat as being there and nuclear products being there, but they really have nothing to do with each other. One might be chemical, one might be nuclear, whatever. I personally believe that it's a unified phenomenon, and it will ultimately be explained as a unified phenomenon, or a collection of phenomena. And the general categories of explanation, I believe, just for your information here, is not necessarily just purely DD fusion. In fact, it probably isn't just DD fusion in most cases. I don't believe that it's pathological science. I don't think it's weak enough to be an unknown chemical or mechanical storage phenomenon. I tend to go with the classical line at the moment, the mainline cold fusion thinking, that there are nuclear reactions with products commensurate with excess power, although we could even have stage 4 explanation, which is something else even more wonderful. tapping of zero-point energy, or something else we've not even thought of yet. In any event, I tend to have my bets with these two. If we're going to go into space with cold fusion, we will need engines to be powered by electricity or by thermal means. There are ion engines off the shelf. You can buy these now. They are space qualified. They accelerate ions to very high velocities, thus the specific impulse ranges not just to around 1,000, but from 5,000 to 100,000. They haven't gotten 100,000 yet, but they've got 5,000, a bit above. This one is made in the UK. It's an ion engine. Basically, you ionize mercury or cesium or argon, and here's another view of it. So you can just hook up electricity to this high voltage electricity source in space and go with very low thrust to weight, less than 10 to the minus 4 thrust to weight ratio of thrust to engine weight, and go out there with very high efficiency. The problem, by the way, with ion engines is that you have to go very slowly. The acceleration is low, and therefore to go out of Earth orbit to get to Mars, you have to spiral around for months. But you still get there. I hope someday that these concepts of fission nuclear reactors, nuclear rockets, and this is a new type that was featured in Fusion Technology, that infamous magazine. December 1991, by Jones, O.C. Jones, different Jones, the particles, it's basically a particle bed of uranium fuel with moderator, and it's spun up centrifugally, and then hydrogen gas is passed through this way, and then you get thrust. And the idea of particles is that you could get much better thermalization, much better heat transfer, and thereby have a higher specific impulse. Specific impulses for these colloidal core rockets are over 1,600 seconds. And you could even go to what Professor Karabrock at MIT once postulated, a gas core rocket, where the uranium fuel is literally a vapor. It's in a vortex or contained in a quartz light bulb or something, and get up to specific impulses of 6,000 or beyond. Well, what good will those things do for you? First of all, let's not talk about emissions here. Let me just talk about what we might find out of a cold fusion electric power source in space. We already have, I believe, at least a kilowatt per cubic centimeter, or 3 kilowatts per cubic centimeter. We saw 10 kilowatts per cubic centimeter that Professor Miley had in his experiment. And perhaps with some of these other new ideas in cold fusion, we'll get even higher. But let's just say 3 kilowatts per cubic centimeter in the material, and an electrical conversion efficiency of perhaps only 10% or 30%. We might get a specific, what is called a specific mass in an electric power source in space of these various numbers, that is kilograms per kilowatt electricity output in the electric power generator, if we had various multiplication factors times the mass of the PD or whatever other cold fusion substrate we're talking about. It might be possible to have specific masses of the electric power source for the ion engines in the range of 4 to 40, or perhaps if we have higher efficiency of conversion, even much lower. The current technology is about 50 kilograms per kilowatt electric. I don't know whether these numbers will ever be achieved, or perhaps they're too conservative, but it seems to me that since we don't have shielding requirements for cold fusion reactors, unlike the SP100 reactor, which is being built, planned, what have you, it'll be a lighter power source. All right, thank you, Hal. Well, what do these things buy you? What do these various performance parameters buy you? This is from a very fine report, and those of you who are curious about space exploration, I encourage you to get NASA Technical Note D6968, September 72, and look at the kind of ways that engineer W.E. Mokel of NASA Lewis Research Center looked at the problem. Basically, we have different parameters characterizing space engines. And they are specific impulse, which I've already discussed, which is exhaust velocity, specific mass, which is the power density, mass per kilowatt electric in the case of electric engines, but in the case of non-electric engines, to make a continuous comparison here, it's the exhaust power, the power in the exhaust. Okay? And we have thrust-to-weight ratio shown by these parameter lines. 10 to the minus 5th thrust-to-weight ratio, 10 to the minus 4th, down to 1. Chemical rockets are here, very high thrust-to-weight, 30 to 60 times the thrust is 30 to 60 times the weight of the engine, or the mass of the engine. Chemical rockets are down here, but they're limited in specific impulse. They're way down. Solid core rockets, fission rockets, go higher specific impulse, and still pretty hefty thrust-to-weight ratios, thrust-to-mass ratios. The type 2, that's type 1 propulsion, okay? High thrust-to-weight generally, and limited by specific impulse. Type 2 propulsion is the ion engine, nuclear electric kind of system, which we could build today. We could use a fission reactor in space. But of course, there's a lot of problems with fission in space or launching off the Earth. People don't want these things. Not only do they not want them leaving the surface of the Earth and polluting through the exhaust stream, but they don't want them crashing back down on Earth. I'm not so fearful of it, but they are, and that's why I don't think they're going to be built. If we're going to use nuclear power to go into space, I think we're going to have to use cold fusion. And I think what we will have is, in effect, cold fusion nuclear electric systems, but with higher, or shall I say lower specific mass. Lower mass per kilowatt electric power required because of shielding and because of other novelties that I think will emerge in that field. But I can't predict for sure what will happen. This is technological forecasting. Just 2 more slides here of any major technical nature. Where does this get you in the solar system with the various types of systems? Distances and systems. Mars, Jupiter, Saturn, Uranus, Neptune, Pluto, out in astronomical units from the Sun, and the various types of specific masses required, or specific masses required to achieve round-trip, rendezvous, and flyby systems. This is type 1 propulsion, this is type 2 propulsion. Better graph is this one, where we combine the 2 types of propulsion on the same graph, and we find that there's a crossover point in terms of the trip time. That also had trip time, the previous graph. All right. You pick your trip time that you will accept, and then you go over here and you find out what kind of propulsion system performance you need to get to a certain location in the solar system. And you also find the crossover points where the type 2 system becomes better trip time-wise than the type 1 system. And just to end with a little flash, another idea of Clark was to have electric generators, again the color's not coming through, to use an electromagnetic launcher on the moon to launch mass into lunar orbit, which could then be used for a variety of space activities. Space colonies on Mars, which, whether or not cold fusion is true, and of course it is true, we will have them, but I think they will be largely benefited by cold fusion. And maybe we'll power an asteroid into space someday. And just to show you that I'm open-minded, I believe that hot fusion should be continued, mainly for the purpose of certain types of plasma fusion engines that will be of great benefit because they have higher thrust to weight in space. And although I would say that we shouldn't be talking about the tokamak reactor, Dr. Teller has a paper infusion technology in which he says D-helium-3 reactions are better for those kinds of missions. And I'll just close with this. Possibly off to the stars someday with an ion engine carrying cold fusion reactor. That's all I have to say. Any questions?
Just 1 or 2 questions real quickly. Okay, we're ready for our next speaker then. Dr. Chirkanoff is in my opinion, is the world's expert at making ball lightning. He's going to discuss a new topic that he's been working on with us. Dr. Chirkanoff.
years I'm working in the field of free energy from mainly from ball lightning. About 2 years I'm working in the field of cold fusion. I have my direction in cold fusion, plus gas loading technology. We have our company Space Energy. I'm president of this company in Salt Lake City. So we have 2 divisions, one ball lightning, another is space energy. I call cold fusion my direction space energy. I don't agree with fusion. Many years ago, theoretically, I proved existence of quantum boundaries with go on. Inside, in this area, matter is normal, all laws of physics are in force, but when we create conditions, matter to be close to these quantum boundaries, then happens very unusual phenomenon. These quantum boundaries replace these laws of physics. They violate these laws of physics, even though all conservation of energy, all gravity and so on. Last few years I created few generators, ball lightning generators. You see here up there, this is a robotic ball lightning generator, absolutely robotic system, which produce artificial ball lightning, demonstrate all features of ball lightning, and prove that this object can produce excess power. Here about 40%. But now we are working for self-contained generator ball lightning, which could produce 100 to 1,000 times more output power. About space energy, cold fusion. You see, this is part of these quantum boundaries. I explained mechanism of cold fusion two mechanisms, depending of how fast is this process. For example, in the case of Fleischmann and Steve Jobs effect, we have a very old process of saturation of metal, palladium, with hydrogen, carrier like hydrogen. At the beginning, when saturation is low. So, by the way, this coordinate, this is space dimension. In this case, this is distance between 2 neighbors atoms, hydrogen, and this is the kinetic energy. At the beginning, we are here, not interesting happening, but saturation goes on, density increase, and we get closer to the quantum boundary. At that moment happens very unusual phenomenon. In order to avoid this, to cross these quantum boundaries, nuclear hydrogen atoms in the metal becomes to move very fast. Hydrogen ions, they becomes to move very fast, and that's a reason, that's a source of this excess power. In this case, we have violation of all conservation of energy. Maybe this is crazy, but I observed this phenomenon in ball lightning for many years. I observed this phenomenon here too. There's violation of all conservation of energy in this case. In the case of cold fusion, you see a few different reactions. I introduce, for example, deuterium. You see, byproduct could be tritium, helium-3, helium-4, and so on. I introduce so-called hydrogen charge. In first reaction, you see that this whole hydrogen charge is observed, so first reaction is more probable. Because of that, we observe more tritium than another byproduct. I mean, in the case of using of deuterium. Second reaction, production of helium-3, or third reaction, you see that all conservation of hydrogen charge are not observed, so these reactions are less probable. I prove theoretically existence of fortune. This is heaviest isotope of hydrogen. This isotope could exist only in metal layers of palladium of metal. Out in the plasma, you know that this resonance of hydrogen also observed, but this resonance which live very short time. This not resonance, this is just isotope of hydrogen, supercarrier, which can live enough long time, maybe a few seconds, maybe more. Cold fusion is accompanied by a very unusual phenomenon. Chemical properties of the crystal metal layers dominate the nuclear characteristics of an atomic nuclei here. Because of that, we observe very unusual nuclear reactions. I would like to say that in case of cold fusion, we have, when we use deuterium, we have ordinary hot fusion. Hydrogen nuclei, deuterium, because of this quantum boundaries, I showed already, they start to move very fast. Very fast, they violate all conservation of energy, and some of them, which have enough high energy, they can collide and to produce some small, tiny hot fusion. Because of that, in the case of deuterium, we observe some nuclear byproducts, but not in the case of light hydrogen. I'm working only with light hydrogen. Ball lightning and cold fusion. For the first time, we observe quantum micro object. Until now, you know, we know about micro electrons, proton, and very particle. Here, in the case of ball lightning and cold fusion, we observe quantum micro object. Ball lightning dimension, average dimension of ball lightning is about 20 centimeters. This is enough big object. This represents giant atom, and cold fusion the same. Ball lightning happens in gas media. Cold fusion happens in metal. We have in some spots creation of this giant quantum micro object, which will be to quantum boundaries. Excuse my language, but another mechanism is works when saturation with hydrogen is very fast, not in the case of electrolysis. This case I use particularly. I call this mechanism, this energy, space energy. I can explain very shortly, but I can say that my work, theoretical work, I proved that, for example, assembly of hydrogen atoms. They have two phases. One is individual phase, so you have hydrogen atoms. They react between them, you know, electromagnetic relay, by gravity, stone, another way. But second phase is their common phase, continuum. This continuum is not empty space. This is matter. When this matter collapse, we have effect of production of energy. When expand, we have effect of production of negative energy. By the way, for first time, we observe here anti-energy, like anti-matter. The same effect, you know, is observed in the case of so-called Casimir effect. Two plates which are in a vacuum chamber and they are cooled down. So in the chamber there's nothing, almost nothing. Thermal radiation is almost zero. They are neutral electrically, so more of a force. But you see, they attract each other. Why? Because this space collapse and they collapse too. Here there's two violation of all conservation of energy. I made many experiments with many setups. I will show only some of them. For example, my first setup, I performed this measuring performance level in parallel with my ball lightning. You see here vacuum chamber. This is this wire. I use now different metal, but Samari Cobalt 5, some modification works best of all. By the way, by contrast with palladium, palladium absorbs well hydrogen, very well, but very slowly. Many hours, many days, even though weeks to reach some percentage. In this case, for Samari Cobalt 5, you can observe very unusual phenomenon. Within only 1 second, it absorbed so much hydrogen that density of hydrogen reached 1023 amplitude particles by centimeter cube. Because of that, here this mechanism of is in force. And I would like to say that very important is time. If you increase pressure very slowly, there's no effect, even though for some speed this effect is appear absolutely. You need to create very drastic change in density of hydrogen. Then this effect appears. Because, look, if you fill hydrogen slowly, like in the case of normal classical cold fusion, then there's no need in variation of observation of energy, because this energy could be taken or given from surrounding medium. But when this process is very fast, within even though 1 second, there's no time. Thermodynamic, there are thermodynamical limits to exchange energy between two bodies, so there's no time. In this particular case, all conservation of energy is violated. In this case, what we observe in this case, first of all, we have to make vacuum in this chamber to avoid any oxygen during 2 hours. Then, during about 2 to 8 hours, we have to activate material, because material is covered by some oxide, and this oxide could be destroyed by high pressure, more than 8 atmosphere. And after destruction of this layer on the surface, material starts to ox, and very well. After few days, usually different time, this material is destroyed because this hydrogen, this density, increase volume. But anyway, after that it becomes particles. We observe that they are more crystals, and they are working even though better, forever. At the beginning, I thought that process starts, but nothing to do. This process continues. I have experiment which lasts 4 or 5 months non-stop. What we observe in this case? At the beginning, this is my first experiment. At the beginning, after a few hours of excitement, there's some raise of temperature of the alloy measured by these thermocouples, and then process stops. Process has to be activated. At some moment, it happens destruction. You of the alloy. We observe very fast decrease of temperature of the alloy, a very increase of the temperature of surrounding object. For example, of these stainless steel membranes. What's the matter? This is unusual for any exchange of energy between two heated bodies. If my temperature is higher than yours, I can give you energy, and your temperature will raise, but not more than my temperature. This is normal. In this case, everything is inverse. Temperature of surrounding may raise, but at the same time, temperature of this body, alloy, wire, happen, it also decrease. The problem here is that inside, in the middle, these very fast hydrogen atoms, at the moment of destruction, they leave the alloy, they kick this stainless steel diaphragm, they hit. At the same time, because energy for acceleration of this hydrogen nucleus is taken partially, one part from metal lattice, one part from I'm excused, okay. So I can't say about the experiment. I will concentrate my attention on practical results. Somebody who does know well my work, they say some chemistry. Nothing to do with any chemistry. For example, before, even though Ponce Fleischmann effect, Steve Jones too, 3 people. Before, for many years, many scientists investigated electrolysis with palladium. Palladium is famous absorber hydrogen. But nobody understood that something unusual happened. They, Steve Jones, Ponce Fleischmann, they had eyes and mind to understand that happened something different. In this case, it's the same. I can show many proofs that it's not chemistry. I made all investigations, toluene, especially toluene 3. For example, one my bar, I produce, I claim 2 kilowatts, 4 kilowatts power. If you make asymmetric regime, you can produce during very long period a lot of power. For only one cycle, you produce 1.2 electron volt per particle. But for millions of cycles, you can imagine how much power. So 1 bar, 2 to 4 kilowatts power. If you make, for example, one experiment, for example, maybe everybody see this my unit, unit. For example, you start from the beginning, nothing in the middle, in this bar, no hydrogen. You put more hydrogen, so this tube has room temperature, 20 degrees Celsius. After that, you fill with hydrogen, temperature is, for example, to 60, even though much more. For example, if you imagine that some hydrates are formed, not chemical, some physical process, combination, some hydrates. And this process is exothermic. Of course, some energy will be produced. But if you discharge, and be careful, if you discharge slowly, nothing. You have very fast change pressure to vacuum. Then effect is this. So if you discharge, by the way, this bar in my experiment, I have colorimeter. They are protected with very good thermoisolation. Temperature drops. If these hydrates are destroyed, temperature of the discharging has to be again room temperature. This low conservation of energy, this cycle, thermal and so on. But no, temperature decrease -4 degrees even though below. This is the situation, the state at the beginning. So no hydrogen. The same, but temperature is low. Only one minute, please go. Of course, I can explain about colorimetry, everything about heat pump. We built many, not many, but enough generators. We have already generators working, so no matter mechanism, no matter theory, we have generators which are working. 5, 8, even though we have 20 kilowatts power generator, which produce hot water. I hope that next year, in a few months, we can build industrial prototype of generators. For example, yesterday, the administration of Hotel Fermini only 2-3 hours to demonstrate. Somebody seen, somebody not. You see, for example, this small generator with system of recycling. I use system of recycling of hydrogen. I use the same hydrogen during long period. Many weeks, many tons, from time to time, put little bit hydrogen because some leak exists. This small amount of hydrogen produces a lot of power. Input power is 1 kilowatt. This model, even though it's not input power, this power is for recycling of hydrogen. Output power at least 8 kilowatts. And another generators, another for research, you know, and so on. Now we have, we don't produce 1, 2, 3, 5 watts physical power like in electrochemical cells. We produce many kilowatts power in continuous regime. And everybody who wants to see our work, he is welcome to come in Utah in our company, Space Energy. I can show him after signing of non-disclosure document because we have filed patents, so no danger for us now. We can show him these generators.
All right.
And then I would like to say that not only because of my English, because I know the situation, this is my right and my request to the chairman of this meeting. I don't want to answer any questions and any comments about my work. I can contact anybody from here out of this because look, in 5 minutes here I can defend me. My English is bad. You can somebody can too much push me. I can defend me. I can defend only my labs in my equipment to show. So please don't ask me questions and no comment about my work. Thank you very much.
Thank you. Yes, one comment, just one comment.
Well, I notice you say that with 1 kilowatt, 8 kilowatts out, which we've heard this summer, many processes not chemistry. None of these proofs were done. It is said that the energy release by the destruction power line is most likely the emission of fast protons. Now, if you have fast protons and you have tens of kilowatts